Hello everyone. Good morning, good evening, good afternoon, wherever you are. This is 3.148, and this is Irodov series. That says that the air cylindrical capacitor at 200 volts is going vertically into a vessel, and it is filled with water. And the capacitor is going at a velocity v equals to 5 millimeters per second, and the plates are at a distance of 2 millimeters. And the mean radius of the plate is 50 millimeters. We have to find the current flowing through it, that is the convection current, the current due to the velocity. Now what I can do is that do what everyone does and say that this case is given, so it behaves like a parallel plate capacitor, and C equals to epsilon naught A by D. So I won't prefer to do that. I would like to give you a sort of little feel about it. So I suppose that you have already derived, you know that the capacitance of a parallel plate capacitor is given by L divided by 2k ln R2 divided by R1. Okay, it's a quite easy derivation. You can use the Gauss law and use the E dot dx equals to potential difference, and you can easily derive it. Okay, so this is the capacitance of a cylindrical capacitor of radius R1 and radius R2. Okay, and we are in this case also we assume that the distance is very less than the length. Okay, so that we can use the infinite condition, and now we know that C equals to this. So we are given that this condition, and we know if this is D, then R2 equals to R1 plus D, right? Okay, so plug in the values. So L divided by 2k ln, what is the value of R2? R1 plus D divided by R1, and the value of capacitance will be L divided by 2k ln 1 plus D divided by R1. Okay, now this is in the form of ln 1 plus x. So we know the expansion of ln 1 plus x equals to x minus x square by 2 plus x cube by 3 minus x power 4 by 4, and so on. So because the d is so small, that so I can neglect all these terms and put the value here. L divided by 2k ln 1 plus d by r1 will be reduced to into d divided by r1. So I have plugged in the values. So this is the value of capacitance, and if you simplify it using the value of putting the value of k equals to 1 upon 4 pi r epsilon naught, the value comes out to be epsilon naught A by D. So yes, it is a cylindrical capacitor, but because of this case, its capacitance can be reduced to this formula. Okay, and now using this formula, if I solve this question, now it is a cylindrical capacitor. It is going in, let's say the x height has already gone into the water. Now since the both parts, now these will be behaving as two different capacitors. So now and both we are at same potential, so they are in parallel. So I can write it C1 and I can write here C2. Okay, all right. Now using the formula, the C equals to so C net equals to C1 plus C2. Alright, then in the parallel it is direct addition. So now what is the value of C1? Is epsilon naught, because it is in the air or vacuum. Area, what is the value of area? 2, if the whole length is L, then this length is L minus X. So what is the area? 2 pi r L minus X divided by D. Okay, D, epsilon naught A by D. And similarly for this, it is this part. So we are not using the epsilon naught, we will be using epsilon. So epsilon is equals to epsilon naught epsilon r, and in the case of water, the epsilon r is 80. Okay, and into 2 pi r x divided by again D. Okay, now if I simplify it, the capacitance comes out to be, now I don't want to take much of your time, it is simple, it is a simplification. So the capacitance comes out to be 2 pi r by D epsilon naught L minus X plus epsilon r X. Okay, and we do know what is Q equals to CV. Okay, so because the C is changing, capacitance is changing because the X is changing. So if I do it right there, so 400, because the value of V is 200, so 400 into pi, what is the value of R? The value of R will be 2 millimeters. So into 2 into 10 power minus 3. We know the value of epsilon naught. We know the value of D, that is 2 into 10 power minus 3. Sorry, I made a mistake here. It is 50. Okay, 50 millimeters. Alright, and then L minus x plus epsilon naught x. So Q is this, and if you put in the values, it's L minus x plus epsilon r x. So now if I have to find the current, I will have to differentiate the Q with respect to time. Okay, so I current equals to dq by dt. Now using that, I will find it the value to be 400 pi into 50 into 10 power minus 3 epsilon naught divided by 2 into 10 power minus 3. It's quite boring. Okay, and using this, it is so v epsilon r minus 1. Okay, because the dx by dt will be velocity, and the dl by dt will be 0. So now putting in the values, putting in epsilon r equals to 80, we get the current to be 0.11 into 10 power minus 6 ampere, or simply 0.11 microampere. I hope you got the concept. I'm going very fast because I can't record very long videos, and I hope that I tried my best to deliver the concept. I hope you like it. Thank you.